The James Webb Space Telescope, JWST, is recognized as the leading global observatory in space science. Its primary mission is to explore the mysteries surrounding both our own solar system and distant exoplanets orbiting far-off stars, as well as to investigate the intricate structures that make up our universe and our place within it. In a groundbreaking initiative, scientists recently pointed the JWST toward a star located 120 light-years from our solar system. In doing so, the powerful telescope uncovered compelling evidence suggesting the presence of carbon-based molecules in the atmosphere of a potential ocean world far beyond Earth, which has left the astronomical community astounded. But how is this remarkable discovery possible? This revelation offers an intriguing look at a planet that stands in stark contrast to any found within our solar system, while also raising thought-provoking questions about the potential for habitable worlds elsewhere in the vast expanse of space. Join us as we delve deeper into this discovery of an exoplanet and uncover the fascinating details it holds. If you're keen on staying informed about the latest discoveries concerning the universe and beyond, be sure to subscribe to our channel, like the video, share it with others, and activate the notification bell to stay up to date. NASA's James Webb Space Telescope has made a significant discovery regarding the exoplanet K2-18b, a planet that is 8.6 times more massive than Earth. What makes this image so special? This exciting finding includes the identification of carbon compounds such as methane and carbon dioxide in its atmosphere. The telescope's detection adds weight to earlier research suggesting that K2-18b might have conditions favorable for life. It seems to possess a hydrogen-rich atmosphere and a surface covered by oceans. The first analysis of this exoplanet's atmospheric properties, situated within the habitable zone, was conducted using NASA's Hubble Space Telescope, which dramatically enhanced our understanding of the system. It's crucial to note that K2-18b resides 120 light-years from Earth, located within the constellation Leo, and orbits a cool dwarf star known as K2-18. This star lies within the habitable zone of its system. Exoplanets like K2-18b, which fall between the sizes of Earth and Neptune, are a rare category in our solar system due to the absence of similar planets in our immediate vicinity. The possibility that K2-18b harbors a significant amount of carbon and a hydrogen-dominated atmosphere is intriguing to astronomers. Many experts believe such planets may offer ideal conditions for the search for signs of life. The presence of methane and carbon dioxide, along with the absence of ammonia, strengthens the hypothesis that this exoplanet might contain an ocean beneath the hydrogen-rich atmosphere. Early research has also suggested that dimethyl sulfide, a chemical compound produced by life on Earth, might be detected in K2-18b's atmosphere. On Earth, most dimethyl sulfide is generated by marine plankton, but the evidence for this compound on K2-18b remains weak and requires additional confirmation. Further observations using the JWST telescope network should help determine if dimethyl sulfide is indeed present in the atmosphere of K2-18b in significant amounts. One astronomer from the University of Cambridge clarified that while K2-18b lies within the habitable zone and contains carbon compounds, it does not automatically imply that life can exist there. The planet's radius, which is 2.6 times that of Earth, suggests that its core might be surrounded by a thick, high-pressure mantle of ice similar to Neptune's. Additionally, it has a thinner hydrogen-rich atmosphere, and its surface is ocean-covered. Although liquid water oceans are anticipated on this exoplanet, there remains the possibility that these oceans may be too rigid or inadequate to support life. However, researchers have succeeded in obtaining the most detailed spectrum of a habitable sub-Neptune planet to date, enabling them to identify the molecules present in its atmosphere. A member of the Cardiff University team explained that this challenge was met by analyzing light from K2-18b's host star as it passed through the planet's atmosphere. K2-18b is classified as a transiting exoplanet, meaning its brightness diminishes when it crosses in front of its host star. This is how NASA's K2 mission first identified this exoplanet. During these transits, a portion of sunlight passes through the exoplanet's atmosphere before reaching space telescopes like JWST. As sunlight filters through an exoplanet's atmosphere, it leaves behind signals that astronomers can use to identify the gases present. The research team intends to conduct additional investigations using JWST's mid-infrared spectrometer to confirm their findings and gather further data on K2-18b's climatic conditions. The team's ultimate goal is to search for signs of life on habitable exoplanets, a breakthrough that could revolutionize our understanding of the universe. Furthermore, the JWST has made other extraordinary discoveries. Astronomers using the telescope have detected complex organic molecules akin to smog or smoke in a distant galaxy. This discovery marks the earliest known detection of such molecules in the universe. Personally, I find this both inspiring and unsettling, as these findings in the farthest reaches of the cosmos are reshaping the very foundations of our cosmology. The importance of this discovery lies in the fact that these molecules, known as aromatic hydrocarbons, were found in a galaxy that formed when the universe was only about 10% of its current age. These carbon-based molecules, which are found in petroleum and coal deposits on Earth, as well as in atmospheric pollution like smog, are large and complex, composed of dozens or even hundreds of atoms. What makes this discovery so remarkable is that such large and complex molecules were formed so quickly after the Big Bang, defying expectations based on our existing cosmological models. To put this in perspective, the light detected from this early galaxy started its journey less than 1.5 billion years after the Big Bang, whereas the universe is about 13.8 billion years old today. This means we are witnessing some of the first steps in the universe's evolution. What is most impressive is that the detection of these complex organic molecules was made possible by the Webb telescope, which will continue to allow us to make similar observations for nearly a billion more years. If we could observe even further back in time, would we be able to find even more of these molecules, perhaps closer to the Big Bang itself? This raises profound questions about our science and our understanding of cosmology. Until now, previous attempts to detect complex organic molecules in ancient galaxies could only confirm their presence. But with Webb's higher resolution, we can now examine the fine details of where these molecules are located. Additionally, the uneven distribution of these molecules in the early galaxy SP4-1847 remains an unsolved mystery. What's truly impressive is that this galaxy was already as massive as our own, with stars that had generated as much carbon and oxygen as those in the Milky Way, despite being only 1/10 the age of our galaxy. As humanity ventures deeper into the unknown, armed with increasingly powerful instruments like the James Webb Space Telescope, we are gradually peeling back the layers of cosmic history. These discoveries not only expand our knowledge of distant worlds and early galaxies but also force us to re-examine the fundamental principles that govern our understanding of the universe. Each revelation made by JWST is a testament to the power of scientific curiosity and innovation. From probing the atmospheres of exoplanets like K2-18b for hints of habitability, to detecting complex organic molecules in ancient galaxies, the telescope is enabling astronomers to explore realms that were previously beyond our reach. The questions raised are as profound as the answers we seek. Could life truly exist beyond Earth? Did complex chemistry begin earlier than we thought? What unknown forces shaped the early universe into what we observe today? These are no longer speculative musings confined to science fiction. They are real, data-driven inquiries that scientists around the world are investigating right now. As the JWST continues its mission, more secrets will undoubtedly emerge from the darkness of space. And with each discovery, we move one step closer to answering humanity's oldest and most profound question: are we alone? So stay tuned, because the journey has only just begun. Knowledge and insight. We are humbled by the vastness and complexity of the cosmos. With every scientific breakthrough, we move closer to unraveling the mysteries hidden in the stars. As our cosmic exploration network continues its work, it's only a matter of time before the universe reveals more of its secrets, shining ever more brightly. Let us know your thoughts in the comments section. If you enjoyed the video, don't forget to subscribe and turn on the notification bell. As we advance in our understanding of the universe, the James Webb Space Telescope continues to provide us with groundbreaking insights. Its observations are reshaping our perspective on exoplanets and other celestial bodies, pushing the boundaries of what we know about the cosmos. This extraordinary telescope allows us to peer deeper into space than ever before, uncovering mysteries that have long eluded scientists. The discovery of complex organic molecules in distant galaxies is just one example of how JWST is transforming our knowledge of the universe's early stages and its ongoing evolution. One of the most fascinating aspects of these findings is the possibility that life, or at least the building blocks of life, may exist in places we once thought inhospitable. The detection of carbon-based compounds in the atmospheres of exoplanets like K2-18b opens up new avenues for studying potential biosignatures on planets that may resemble Earth in some ways. These compounds, including methane and carbon dioxide, are often associated with biological processes here on Earth. However, their presence in distant worlds does not guarantee that life is present. Instead, it prompts further investigation into the conditions that could support life elsewhere in the universe. The Webb telescope's ability to analyze the atmospheres of exoplanets with such precision is a significant leap forward. It allows scientists to detect not just the presence of basic elements, but also the complex molecules that might indicate the existence of life. This level of detail is crucial for understanding the potential habitability of distant worlds. As our understanding grows, so too does our ability to detect subtle signs of life, whether they are in the form of atmospheric gases, organic molecules, or other markers that could point to biological activity. In addition to its work on exoplanets, the JWST is providing valuable insights into the formation and evolution of galaxies. By observing distant galaxies, astronomers are able to trace the history of star formation, the distribution of elements, and the processes that drive the growth of galaxies. These observations are crucial for understanding the origins of our own galaxy, the Milky Way, and how it has evolved over time. The discovery of aromatic hydrocarbons in a galaxy that formed only a fraction of the time ago compared to our own is a testament to how much we are learning about the early universe. As we continue to explore the cosmos, each new discovery brings us closer to answering some of the most profound questions in science. Are we alone in the universe? What conditions are necessary for life to thrive? How did the universe evolve, and what lies ahead in its future? The James Webb Space Telescope is providing the tools necessary to address these questions, offering a window into the farthest reaches of space and time. In the coming years, we can expect even more groundbreaking discoveries from the JWST. Its ability to study the early universe, exoplanets, and the fundamental processes that shape the cosmos will undoubtedly lead to new insights that challenge our current understanding. The potential for discovering new planets, studying their atmospheres, and uncovering evidence of life beyond Earth is more promising than ever. With each observation, we are reminded of how much there is still to learn about the universe. The Webb telescope, with its unparalleled capabilities, is leading the way in our quest for knowledge. It is not just a tool for astronomers, it is a symbol of humanity's curiosity and drive to understand the cosmos. As we look to the future, we can be certain that the discoveries made by the JWST will continue to inspire and transform our understanding of the universe, helping us answer questions that have fascinated humans for centuries. As the telescope continues to scan the skies, we can only imagine the incredible breakthroughs yet to come. Whether it's the detection of new exoplanets, the exploration of distant galaxies, or the discovery of life in places we never thought possible, the James Webb Space Telescope is at the forefront of space exploration. Its mission is one of discovery, one that will shape the future of astronomy and our understanding of the universe for generations to come. This journey is not just scientific, it's deeply human. The pursuit of knowledge, the desire to understand our place in the cosmos, and the hope of finding connection beyond Earth are all reflections of our collective spirit. Each image captured, each spectrum analyzed, and each paper published by the JWST adds a brushstroke to the grand painting of our universe's story. Collaboration across nations, institutions, and disciplines fuels this incredible endeavor. The James Webb Space Telescope is not the achievement of a single country or group, it is the result of global cooperation, symbolizing what humanity can accomplish when we work together toward a shared vision. As more data flows in, researchers around the world are poring over the results, building models, forming hypotheses, and challenging assumptions. This dynamic exchange of ideas ensures that the discoveries made are not only interpreted but understood in ways that spark further inquiry. The telescope's ability to look back in time, seeing light from galaxies formed just a few 100 million years after the Big Bang, gives us unprecedented insight into the infancy of the universe. It helps answer questions about the very fabric of space-time, the distribution of matter, and the forces that govern cosmic evolution. But even as we peer into the ancient past, we are also looking forward. The JWST's capabilities open up possibilities for future missions and technologies. The knowledge we gain today will shape the objectives of tomorrow's telescopes, spacecraft, and perhaps even crewed missions to distant worlds. We stand on the edge of discovery, facing a universe vast and filled with promise. And though we may not have all the answers, the pursuit itself enriches our understanding of what it means to be human. The James Webb Space Telescope is more than an instrument, it is a beacon. It lights the way not only to the stars, but to deeper questions about existence, creation, and our shared destiny in the cosmos.